So did you get the derivative of cotangent x? Well, let's see if you got the same thing I did. So it's going to be the derivative of cosine over sine. All right, so this is f, this is g. F prime is negative sine x. G prime is cosine x. So if I do f prime g minus f g prime over g squared, then I get negative sine times sine, so negative sine squared, let's just put that right away this time, minus, for my minus here, f g prime, so that's going to be cosine squared, and in my denominator I have g squared, so that's sine squared. Okay, so what am I going to do with all this stuff? Am I going to cancel the sine squareds? No, because you cannot reduce over a plus or minus sign. That's why we didn't do that before. What you can do is factor out a negative 1 from the top. So this is negative 1 times sine squared plus cosine squared over sine squared. So that's negative 1 over sine squared x. And that is negative cosecant squared. All right, so now we know that the derivative of cotangent is negative cosecant squared. What about the derivative of secant? Pause the video, work that one out. Okay, so we're going to say it's the derivative of 1 over the cosine x. Now look, we're going to learn another way, a simpler way to do this, but we can do it with quotient rule. We can go f and g and go f prime is 0, g prime is negative sine x. Sure. Secant is 1 over cosine, yeah, that's right. Okay, so then my derivative is going to be f prime g minus f g prime over g squared. So that is, f prime is 0, so I'm going to have 0, minus negative sine x, so it's going to be plus sine x, over g squared, which is cosine squared. Okay, so I get sine x over cosine squared x. So, by the way, if you look up what the derivative of secant x is, you're never going to see anybody write it's sine x over cosine x. What you're going to see them write instead is, since this is equal to 1 over cosine x times sine x over cosine x. See, look, by the way, this is why you learned trigonometric identities. So when you were in pre-calculus and you were going, why am I doing all these identities? This is why. So you can look at the derivative of secant x, instead of saying it's sine over cosine squared, which nobody says, you're going to go 1 over cosine is secant, sine over cosine is tangent. And what you're going to say about the derivative of secant x, you're going to say it is secant tangent. All right? With the same thing in mind, you find derivative of cosecant x. Go ahead, try it. Pause the video, try to find derivative of cosecant x. Okay, hopefully you've done that. So this time it's 1 over sine x. So that is going to be, here's my f, here's my g. F prime is 0, g prime is cosine. So when I do f prime g minus f g prime over g squared, I'm going to have, my f prime is 0, so I have 0. Now it's minus f g prime, so minus 1 times cosine, so minus cosine x over g squared, which is sine squared. So I have negative cosine x over sine squared. So this is equal to negative 1 over sine x times cosine over sine x. So what most people are going to say for that is negative cosecant cotangent. All right, so now you have 4 more derivatives to add to the derivatives that you should know. So you don't have to derive these every time. You're just going to know when you see derivative of cotangent, you're going to go, oh, I know that's negative cosecant squared. How are you going to know that? Because you're going to memorize it along with all these. So here you are now ready for the colossal compendium of derivatives. I wrote this for AB, but you do the same derivatives for BC, so there's nothing different about it. All right, here's all the ones you already knew. X to the n is n x to the n minus 1. That's your power rule. Derivative of sine is cosine, derivative of cosine and negative sine. Now here's the new ones we're adding. Derivative of tangent is secant squared, derivative of cotangent, negative cosecant squared, derivative of secant tangent, derivative of cosecant, negative cosecant cotangent. Here's some other ones you already knew. E to the x, ln x, 1 over x. Here's some you didn't know. A to the x is a to the x ln a. I think we're going to do that next time. Log base a of x is 1 over x ln a. Now, these are all inverse trig functions, okay? We have to do some more sections before we can get these, so you won't have to know these yet, and you don't really have to know these two yet, all right, the a to the x and the log base a of x, but already we need to know all of these, so start working on knowing those. On the back of the Colossal Compendium, I put the rules, the product rule, the quotient rule, and what we're going to learn next time, the chain rule. That's for next time. Okay, so all of that is in the Calculus Colossal Compendium of Derivatives. These are all things that any calculus student, any Calc 1 student, an AB student, just knows all of this. You just know it all. By the way, however, the inverse trig ones tend to be not as well known by calculus students generally. You just want to know, yeah, it's something with a square root and I have to look it up. All right, that's fine. If you can say that, you know it well enough. All right, so that is a resource that is available to you. It is on Google Classroom. It is on the website. You now are able to apply the quotient rule and the product rule to do homework. Your homework will include product and quotient rule practice. That is a worksheet that is posted on Google Classroom and on the website. So your homework is product and quotient rule practice. It's called that, and it is in the website in Google Classroom. And additionally, since you now know all these nifty trig derivatives, we can also do some of the ones we skipped from section 3.3, which is page 114. That's chapter 3. And it is, I'm going to do page, I don't want to overwhelm with these, but I wanted to pick some good problems. So, oh, did I lie? It's page 146. Yeah, page 146. And then I write it twice and wrote it wrong both times. Page 146. Here's the ones I picked. Number 4 through 10, all. Number 21 through 23, all. And 27, 28, 30, and 31. Carefully selected problems for your calculus studying enjoyment. And I'm not sure how the schedule is going to work. Probably this is going to be due Friday, but don't quote me on that. Or actually, no, I decided I wasn't making homework due Friday anymore. It's going to be due next Monday. I think however they do the schedule. This is going to be part of homework number 8. Are we on now? Going to be due next Monday, okay? But whatever I say in the video, sometimes I'm just making it up. And look on the homework page of the website because that is the final word on what is due when, okay? And I'll try to clarify it on the Google Classroom as well. All right, enjoy.